In the previous video, we reviewed how you would graph an inequality and what it actually meant. Now we're going to work on how to solve an inequality, and then the graphing will just be a end point or an end task after that. Good news, solving these inequalities is going to be not very different than solving an equation. Here's an original inequality. My goal is to get x by itself, so I have to get rid of the subtract 3 and the divide by 4. As you know, I would add 3 to each side to get the next step. And then as you know, I would divide each side by 4 to get that. And now what I have is a solved inequality, and then I can just simply graph that on the number line. X is less than or equal to 5. The equal sign underneath says close circle. I need to close or shade all values. You can go either way, this type or this type, that are less than 5. And that's all I have to do. Now here's a great way to check yourself. Pick a number from the shaded region. I'll pick 2, but I could pick anything like 1, 0, -1, -2. So I'm going to test x equals 2. This isn't necessarily part of the problem solving, but it can let you know if you're correct or not. So I'm going to take that x equals 2 and I'm going to plug it back into the equation. Back into the inequality. And if x equals 2 is correct, or if my solution is correct, x equals 2 is going to make this true. So now I would just go ahead and plug in the 2. And I get 5 is less than or equal to 17. That's a true statement. So that is verification to me that when I picked a value from the shaded region, it made the inequality true, which is an indication to me that my answer is correct. All right, let's do another one here. My goal is to solve for x in this inequality. I move the 3 to the other side by doing subtract 3, subtract 3. Now I just have a 3/4 x on this side. How do you get rid of a fraction? You multiply by the reciprocal. And when I do that, cancel, 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 I get x by itself. And if you take a -9 times a 4/3, do that thing on your calculator, you're going to get a -12. So I've got this awkwardly written statement. I could say x is greater than -12, but I really have my answer. Now I just need to graph it. Be careful when you make your number line, because in the land of negatives, you can easily screw that up. It would go this way. With a continuation going to the right, I would eventually get to 0. 0 is bigger than -12. Now I graph it. I look at this. This tells me I have an open circle. I'm not going to include -12. And I shade x greater than -12, anything to the right, or shade like that, whatever you prefer. And now you're done with that problem, but I'm going to do a quick check just to see if I really did get a good answer. So remember to check to see if you're correct. If you feel like checking, choose a value from the shaded region. Well, I didn't want to work with these messy negatives, but I know if this graph continues on forever, eventually over here is x equals 0, and that's in the shaded region, so it should make my inequality true if I plug it in. And 0 is really easy to work with. So here's my original inequality. I plug in an x equals 0, and now the great thing is 3/4 times 0 is 0, so I'm just left with a 3 greater than -6. Is 3 really greater than -6? Yes, it's true. That's a good indication that I've solved this problem correctly. What you're about to see here is probably the only new thing from these inequalities, and as you might guess, there's some danger for algebra students here. Here's a statement that you kind of have to memorize. Whenever you multiply or divide by a negative number, you must flip the inequality sign. If you don't do that, you'll get literally the exact opposite answer of what you should do. So I'll show you what that means. Here I have to solve for x, so I move the 12 to the other side. I still need to get x by itself. That means I need to divide by -5. Well, look at this. This statement says whenever you multiply or divide by a negative number, you must flip the inequality. I'm dividing by a negative. That means I have to do this. So these reduce. I must flip the inequality. That's what that warning is telling you. And 20 divided by -5 is -4. So if I make my number line, be careful because I'm in the land of negatives. It's easy to mess up that number line. X is greater than or equal to -4. It's a closed circle, and I shade anything to that side. So now if I wanted to test myself to see if I was correct, I can do it, or I can just believe that I'm correct and move on to the next problem. I'm going to test myself. It turns out I was correct. I took my original inequality. I chose a number from the shaded region. I chose 0 because 0 is easy to work with. And when I plugged it into my inequality and worked it out, I got 12 is less than or equal to 32. That's certainly a true statement, so I believe that I am correct. The big deal was when I divided by a negative, I flipped that inequality sign. One last problem here. And notice that I have a -3 in the denominator. That's going to end up being a big deal. We're going to have to heed our warning. I'm going to go ahead and finish these steps, and then I'm going to pause it while I do it, and I'll show you what happened. Okay, here's what happened. I moved the 4 to the other side, and that's how I got that -6. So at that stage, I had to get rid of the -3. The -3 is attached by division, so I had to multiply each side by -3. That's where it happens. Whenever you multiply or divide by a negative number, you must flip the inequality. I multiplied by a -3. When I did that, I had to flip that inequality. Easy to forget that. Now I have x by itself. I graph it. I could test a point, but I promise you I'm correct on this. And kapui. We have now learned to solve inequalities, remembering that the one new thing to learn is this statement right there.